generally to these other places. And if you squint at this, it starts to kind of look like one of the holy grails of programming. Right? It kind of starts to look like an executable, an English executable specification. Right? I read it to you, and if you think about the description you would give of the incrementer button, it's not very far from this, except maybe the wing setting default's part of it, right? And that's obviously pretty surprising and like really interesting. Right? Again, this is one of those things we've wanted for forever. But we found out that actually this way of programming isn't that great. A lot of people still think that the English specification is like the future of programming. If we ever get there, we've made it and we're kind of done. And I don't really believe that's true. The reason why, after having programmed this way for a little while, is that if you read an English specification, every line of that English requires you having understood and internalized every previous line that was written. Right? When you think about a big part of what makes programming hard, right? A big part of dealing with complex systems is being able to box parts of them up. Right? Like, I don't even know about this, I don't even know about this, I can just like go with this. And these English specifications require you to basically understand the whole thing all the time. And you're almost sure, so maybe you could reasonably do that. But when we actually tested this out with people and sat them in front of it, they were like, I can read these programs, I get what they're doing. No one was successful in writing one, right? Which is kind of interesting. And maybe it was like tooling, maybe it was like strategy, maybe it was whatever. But I think it's probably actually more fundamental than that. Like I said, I think it has to do with this context problem. That every line requires the context of all the previous lines. And so again, okay, let's try something totally different. We know this Excel thing works. What could we make it look like Excel, right? And so we suddenly realized that these operations you could perform visually on tables, because that's basically what was going on here. And so this example is pretty hard to see, so don't worry about it too much. But what I'm doing is, this is the first time you interacted with the outside world, it sends us a text message. And so we have a set of buttons down here at the bottom which you can't read, but it has our names on them. And if you click one of those buttons, it's going to send that person a text message. And the way this worked was that there were these tables inside of our system that had like event information in them and had the people in them, and then we would join those two things together. And now you can see every time I click one of these, it had the information for Chris or Jamie or Bob, and had the fake version of our phone numbers. We actually did give us our real phone numbers at one point. So it's kind of like writing this thing in Excel again, with some more interesting abilities than Excel usually has, right? We can join things. It had basically the properties of a relational database. And this was neat. It worked for some definition of works. And not to give you relatively simple things, but we found a bunch of problems with it. For one, once you had this nice little table, you lost all context of where any of this information which when you're building things is actually pretty important information to know. You just have these values, you just have kind of like random names. But it did kind of prove to us that you could start maybe treating this as a very different problem. Maybe instead of thinking about like writing code, even if it were English code, maybe you could think of it as like operations in these tables, and you could do it very visually, and you could do it almost essentially just mouse-driven, right? And it could look like Excel. We sort of ran into a bunch of roadblocks here, like I said. Like, just like a very simple example of this is not knowing where anything came from. But as you started building up these more complex tables, you realize that people don't really think of the data this way. They have to think about keys a lot, right? And like joining on the keys, and it was still pretty hard. It wasn't the right solution. And shortly after this one, they were like, well, guys, I don't know yet about how to do the whole, like, make this thing accessible, but can we at least prove that it's a good idea? Like, the foundation of this is a good idea. Because we essentially broken this problem up into several problems. The first was, can we find a version of programming that was very simple, right? And by that I mean a few parts. And that version of programming has to be something that I could use, as well as it's going to work on Excel-like problems too, right? So it had to be a general purpose language, but it needed to be very simple. And so we really liked the stuff out of the Boon Lab, and we had built some interesting things, but we wanted to deal with it more. We wanted to really try and develop some stuff with it and see what happened. And so we built this prototype, which, given how much time do I have? Not too much time. I'll show you very, very briefly what this looked like. So you had this thing, don't worry about what this looks like. So here's a clock, right? So we can zoom in a little bit. And everything in this language, like I said, it's just a kind of SQL, basically. It's kind of this new way of thinking about the world. All we're doing is query. And specifically, actually, we're building views in our case, which are queries that are always up to date, more or less. And so the very first thing sticks a row in a timer table, which generates a timer for me. And that's what runs this clock. And then down here, we have this line which pulls in from the time table, which is what that timer sticks values into. And then we aggregate over that time table to get the latest time, and then we just turn it into hours, minutes, and seconds. Right? And then we draw a clock, and this is just me being bad at math. And then we have this little language down here that allows you to describe UI. Right? And what's interesting about this language is you never describe how things change. Because all we're doing is like ask a question and formatting the result of that question. You can all sorts of crazy things this way. Yeah, get the clock. That's interesting. Of course, we get to MVC. You can't not have to MVC. We also get the Turing machine, just to be sure. So that, is in there, and what's interesting is, once again, we bootstrapped it. So everything you saw being rendered on the right-hand side, all those tables, all of the UI, even, so this thing is actually pushing processes distributed, so like it would run your program in another thread, and then subscribe to that other thread and pull data in. This entire little thing here was written 200 lines. This is all right here. So again, this is like totally, like crazy way of thinking about the world, but it kind of works, right? And so it's from this code. Operations on a B tree, which is what a query language ends up doing. And we do that kind of by default. But there's still lots of interesting work to do there. But the foundation is solid. The foundation is the kinds of things we want to express, and we just have to figure out how to show it. Oops. Let me get back to my presentation. So we tried again. This time, I don't know why, but we ended up going back to the Excel thing. But this time we had something a little bit more interesting, which was you could actually build UI, and this was the first time that you had like a drag and drop UI builder. And it's a little hard to see, but I dragged out a button there, right? And we're going to build the incrementer example. And I'm going to give my button a name, we'll call it incrementer, and this little button down here that says get the clicks for that button, which is just a table. Everything is always just a table, right? If data's going to come from the outside world, it gets shoved into a table. If we want to do something to the outside world, we shove it into a table, and something out there kind of looks for it and does something with it. So every time I click, I got a row in this table, and then the incrementer button is just counting the number of rows in the table, right? And this had the Excel thing going on, so you have like an Excel formula in here, you said count them, and then you could just drag that column onto the button, and that was now bound, now it's sort of data bounded to the button. And it was asking you what to bind it to, you bind it to the text, and an incrementer button. So what a problem that took a professional programmer easily 30 minutes to do, assuming they knew what they were doing, and if they don't, who knows how long, could take 30 seconds, right? Like we could be much better at this if we thought about the problem again, suffered from the same problems I described before, which was that you lost all the context when you're building up these tables, and it didn't really fit the model very well. So we tried this other thing where, like, hey, the UI builder thing worked out pretty well. Let's clone Foursquare. Let's clone a production-ready website and see what that looks like. And we built this each time, right, we build a new to try and do this, try and understand it. We test people. This one was good enough to build a production-ready clone of Foursquare. It was abysmal doing it. It was really, really bad. Although not because we lied, that was really dumb. But the way we wrote queries in this was really awkward. We tried to mix the two. So we had the tables, right, and then we had the information, basically the sources of all the information from the tables up at the top, and it kind of looked like a SQL looking language. It was just bad. It's hard to explain exactly what was so bad about it until you use it and you, like, fully realize exactly how bad it is. I don't have enough time to show it, and I don't want to be ashamed, so I'm going to skip that one. But it was still interesting. It was the first time we did not have to write any code to build a real website, right? Like, you could do this purely without typing anything, more or less, which is interesting, again, but it still doesn't write. So the next step after this was what we initially released. So we're all open source, and this is what we pushed out when we open source. And it was based on the situation that, well, all of our attempts of writing queries not in a query language that a programmer would understand have kind of been crappy. But we had the situation that when we passed around queries to each other, we drew them on the board. And we drew them as what looked like entity relationship diagrams, if you know what those are, little bubbles with, lines between them. And we if we draw them that way to explain them to each other, could we make them work? And we hesitated going in this direction because we know lots of problems with this kind of visual programming. And we even built the boxes and arrows version of this long, early in our process and realized this is not going to work. But this is a very different property because what you're describing is not a set of steps or a data flow. You're describing a shape. You're saying, I'm looking in the database for a shape. Right? And specifically, this is a famous shape. It's known as the three-click query of friends, basically. A friend was a friend of a friend was a friend, right? This happens to be a notoriously difficult thing in databases to optimize for. And you'll notice it has this wonderful property. I asked for a triangle, so I represent it as a triangle. This is one of the first times that people seem to understand relatively complex queries without us having to explain much of anything to them. A very simple set of things, and they're like, oh, okay, triangle of friends, it's a triangle, right? And then, here's a slightly more complicated one where you're getting the departments, you're trying to find out what percentage of the total cost each department is. So there's a bunch of aggregations going on in here, and then you're dividing those to get the percentage. And this is really interesting, because like I said, it's the first time people can understand it. It doesn't suffer from the same blowing problems that visual data flow languages do, because your shapes never get that big, right? It's not like you're describing the entire flow of a program, which could be of infinite size, basically. These, we're only asking for some shape, and it looks roughly like this. And so it seems to scale halfway.